Hi, what's going on guys? My name is Enzo and today we're going to learn how to build an NFT. NFT stands for non-fungible token. If you have watched my last video, you will know that cryptocurrencies are fungible tokens. Fungible tokens are identical to each other. One Bitcoin is worth the same than any other one Bitcoin out there in the market. NFTs, on the other hand, are unique and irreplaceable. However, there are also tokens on the blockchain just like cryptocurrencies are. They have been used to represent digital art, property rights, collectible in video games, or even real estate. Do you want to know how to build your own NFT? Let's dive in. But first thing first, I just started this channel and it would mean the world to me if you could hit that subscribe button and like the video so many more people can see my upcoming content. Thank you. So back to our topic, NFTs are defined by the ERC 721 standard. This standard defines a set of the properties and functions that a smart contract needs to implement in order for it to be a valid NFT. I will put these links as well as any other resources shown in this video in the description so you can check them out whenever you want. For building our NFT implementation, we'll be using the Open Zeppelin contracts library. It is a free and open source library that provides base smart contracts for you to build upon with built-in security and best industry practices. Now that we have a starting point, let's code. So looking at the code, I have set up a basic contract called myNFT that right now only has one line, which is importing the Open Zeppelin contracts library. It is importing the ERC 721 contract. And you can see here that it contains all the different properties and functions expected for an NFT to have in order to satisfy the standard. So this will be covering most of the groundwork for us. However, we still have a bit of work to do. The first thing that we need to do is to call the constructor inside the ERC 721 contract. For that, we'll be setting up our own constructor and we will be calling the ERC 721 constructor and passing in two arguments inside it. The first one is the NFT name. We will be calling it myNFT, and the second one is the symbol. For the symbol, we'll be using just MNFT. Then we need to extend the ERC 721 contract. That's done. Now we are calling the constructor whenever we deploy the contract, just before calling our own constructor. Then we need to worry about two things. The first one is the NFT IDs, and the second one is the NFT's URI metadata reference. For the ID, we'll be using another Open Zeppelin contract utility called counters. It is basically a counter that goes from 1 to infinite, that will be incrementing and using its latest value whenever we want to mint an NFT. For that, we'll be defining a function called award item. Next, inside it, we want to do a few things. The first one is that we need to actually create our counter here. We also need to use this using import the counters utilities to be able to access these different functions. And now we are able to call here token IDs dot increment. Whenever we call the function, the token IDs counter will go up by 1. And what we want to do next? We want to capture the current value of the token. So our new token ID will be the token IDs, the current value. Now we have it stored inside this new item ID variable. And afterwards, we are able to call the mint function that will mint an NFT for the given player using the specific ID that we just got. Mint comes from the ERC 721 contract. After that, we are only missing to return the token ID that we just created, right? That would be our basic function. And now we need to worry about the token URI. The ERC 721 has a basic implementation of the token URI, where basically you might define a base URL, and what it will do is, if you have defined any, it will take the base URL and concatenate the ID right after. However, this is most of the time not good enough. it forces you to be using the ID to reference the URI metadata. You also don't have a trailing extension, like you cannot reference a JSON file, which is most of the NFTs right now on the market. And finally, it also forces you to host all your metadata in the same place. Maybe you later need to change servers or something like that, and you cannot just migrate everything. So to implement this token URI missing piece, we have two main options. We might store on-chain the full URL of the URI that we want to point to, and that URI contains all the metadata for that NFT, or we might store the NFT metadata directly on-chain. We'll be doing both to see what are the differences. For the first option, for storing the full URL on-chain, we'll be using this ERC721 extension by the OpenZeppelin contract. This will enable us to store inside the NFT some additional metadata related to that token. In order to implement this extension, we need to first extend the base contract and then set the token URI whenever we mint our new token. Finally, we need to override two different functions, _burn and token URI, because there are collisions and overlaps in the inheritance. This is how you override the functions, just calling sopper, so the underlying functions take the job, and you specify the contracts that you are overriding. Next, it's still complain about a shadow declaration. This is because the URI storage declares a token URI function, so we are going to avoid it by putting some leading underscores, and we'll be replacing the values in the functions so everything works as expected. This would be the implementation for storing the URL on chain. Now let's see how the second option, storing all the metadata on chain, would look like. First, let's create a struct called myData that will contain just a string with a name. Next, you want to declare an array of myData, and this array will store the different metadata for each token. We'll be using the token ID to index the metadata for that specific token. Then we'll go to our item function, and just before the new item ID, we will be constructing our data for this NFT, and we'll pass some name to it. Normally you would get the values for the metadata from the function argument. Here I have a little typo, my data, and my data needs to be a memory struct because it's a short-lived one. Of course, we'll be putting the name that we have just declared, and we'll be using the underscore as the other ones. For the metadata, so now we need to store it somehow, right? So we can just call, all right, so my data is already used, so let's call new item data, and we'll be using my data, so this array here that we have defined, and we will be pushing the new item data into it. This is basically how to create data for an NFT and store it so it can later be picked up. And how we could be picking it up with the function that looks something like this. We'll call getMyNFT as an example. That will receive a token ID. It will be a public function and returns my data. And we'll be returning my data using, as we said before, the token ID for returning the metadata of the token. Here, of course, the metadata needs to be a memory variable once again. And that's your NFT ready to be used. The next steps will depend on your use case. You might want to limit how and when NFTs can be minted, or you might want to make your NFT evolve to another NFT under certain conditions. Really, here the sky is the limit. And that's everything I got for you today. Thanks for watching, guys, and make sure that you hit that subscribe button and turn the notifications on so you don't miss the next juicy videos like this one. Please share it with a friend and don't forget to like the video. Until the next one, keep coding, keep smiling.